Hi everyone. In this video, let's learn how to balance a chemical equation. So before getting into the topic, let's learn what is a chemical equation, why should we balance an equation, and then let's learn how to balance a chemical equation. So what do you mean by a chemical equation? Chemical equation is a symbolic representation of a chemical reaction in the form of symbols and formulae. So let's take an example. H2 plus O2 gives rise to H2O. We need to balance this. Let's balance this equation later. So here H2 and O2 are the reactants and H2O is the product, right? So what are reactants and what are products? Reactants are the substances which take part in a chemical reaction, and products are the substances formed as a result of a chemical change. So these are the information provided by a chemical equation. So chemical equation gives us the chemical nature of the reactants and products, nature of elements and radicals involved, direction of the reaction, whether it is irreversible or reversible reaction, and states of matter. For example, hydrogen is in gaseous state, oxygen is in gaseous state, and H2O is in liquid state. So these are the information provided by a chemical equation. And these are the limitations of a chemical equation, in the sense a chemical equation does not tell us about the concentration, the speed of a reaction, changes in color, completion of a reaction, and changes in light or sound energy. Balancing of chemical equations. So the chemical equation needs to be balanced so that it follows law of conservation of mass, which states that mass can neither be created nor be destroyed. Generally, the chemical equations are balanced by two methods, hit and trial method and partial equation method. But generally we use hit and trial method to balance the chemical equations. So let's take a simple example and learn this better. So there are two baskets here. Let's call basket number 1 and basket number 2. In basket 1 there are 2 oranges, so I'll write 2 here, and in basket 2 there are 2 apples, so I'm writing 2 here. A naughty child comes and mixes up these two baskets, basket 1 and basket 2, and puts in basket number 3. But in basket number 3 there is only 1 orange and 1 apple. He just mixes up the fruits, but he's not losing any fruit, right? So before mixing and after mixing, the number of fruits should be the same. So in that case I'll write 2 here. So 2 oranges and 2 apples. So this is what happens in a reaction also. So when a reaction is taking place, no atom is lost or mass is not lost, means just the breaking of old bond and formation of new bond takes place. That's it. So that's the reason we need to balance a chemical equation if it is not balanced, so that it follows the law of conservation of mass, which states that mass can neither be created and nor be destroyed. So let's take few examples and learn how to balance a chemical equation by hit and trial method. These are the reactants and this is the product. So how many hydrogen atoms are there on the reactant side? 2. On the product side, 2. Oxygen atoms on the left hand side, 2. On the right hand side only 1. So we need to balance the number of oxygen atoms. So in that case, if I write 2 here, so the number of hydrogen atoms also changes, that is 2 into 2 4 and 2 into 1. If at all you don't find any number here, that means it is 1. 2 into 1 2. So the number of oxygen atoms on the left hand side and the right hand side are balanced. Let's balance the number of hydrogen atoms. So in this case I'll write 2 here, that means 2 into 2 4, right? Even the hydrogen atoms on the left hand side and the right hand side are balanced. So this is the balanced equation. 2H2 plus O2 gives rise to 2H2O. So this is the one more example. How many Hg atoms are there on the left hand side? 1. On the right hand side, 1. Oxygen on the left hand side, 1, but on the right hand side, 2. So in that case we need to balance this. So if I write 2 here, the number of Hg atoms also changes, that is 2 and 2. 2 Hg and 2 oxygen. And here we need to change the number of mercury atoms, so I'll write 2 here, which means 2 Hg atoms and 2 O2. So it is balanced. So this is the balanced chemical equation. 2HgO gives rise to 2He plus O2. So this type of reactions where a single reactant split to give 2 or more products are called decomposition reaction. The previous one where 2 reactants combine to give one product are called combination reactions. So here's the one more example. Al plus CuSO4 gives rise to Cu plus Al2SO4 thrice, right? So let's count the number of atoms on the left hand side and right hand side. Aluminium 1 on the right hand side, 2. Copper 1 and here 1. Sulfur 1 and here S3, so 3. Oxygen 4, here 4 into 3, 12. So now the number of aluminium atoms on the left hand side only 1, on the right hand side 2. So I'll just write 2 here. So now this is balanced, right? 2 on the left hand side and 2 on the right hand side. So let's take copper here. So copper 1 and copper 1, so let's just leave it like that. Sulfur 1, but here 3. So I'll just write 3 here. That means the number of copper atoms also changes. 3 copper atoms, 3 sulfur atoms, and 4 into 3, 12 oxygen atoms. So on the right hand side, the number of copper atoms, there is only 1 copper atom. So in that case I'll write 3 here. That means the number of copper atoms are also balanced, right? The sulfur as it is 3, so balanced, and oxygen 12. So the balanced chemical equation is 2Al plus 3CuSO4 gives rise to 3Cu plus Al2SO4 taken thrice. These type of reactions where aluminium displaces Cu from CuSO4 are called displacement reaction. Only the metals are displaced here, right? Cu is being displaced by Al, Cu plus Al2SO4 thrice. So let's take one more example. FeCl3 plus NH4OH gives rise to NH4Cl plus FeOH taken thrice. The number of iron atoms on the left hand side, there is only 1 iron atom on the left hand side and 1 iron atom on the right hand side. Chlorine atoms 3 here and 1 here. Nitrogen 1 and 1. Hydrogen 4 plus 1, 5. And here 4, 5, 6, 7. 4 plus 3, 7. Oxygen 1 here and 3. Right? Now let's balance this. So the number of chlorine atoms changes, right? In this case, if I write 3 here, right? 3n, the number of nitrogen atoms also changes. 3n, 3Cl, right? And obviously the iron remains same as of now. So, and number of hydrogen atoms also changes. 4 3s are 12, right? 12. 13, 14, 15. Now we need to change the number of nitrogen atoms and hydrogen atoms on the left hand side also. So in that case I'll write 3 here. So the number of nitrogen atoms changes, right, and this remains same. And number of hydrogen atoms also changes. 4 plus 1 5 into 3 15, right? So these are all balanced here, yes or no? 3 3 3 3 15 and 15. So let's check the oxygen atoms. 3 into 1 oxygen atom, 3 into 1 3. So even this is balanced. So FeCl3 plus 3NH4OH gives rise to 3NH4Cl plus FeOH taken thrice, and this is the balanced equation. And this type of reactions are called double displacement reactions. So this is our last example. So if we see this big equation, we feel that, oh my god, it is very big and it is not possible to balance. It takes time. But no, it is very easy. Just write down the number of atoms present in the left hand side and also on the right hand side, and it will be very easy for you to balance. So let's just start. On the left hand side, the number of sodium atoms, only one sodium atom. On the right hand side, 2. Carbon, 1, and here 1. Hydrogen, 2 plus 1 3. Here only 2. Oxygen, 4 5 6 7, right? 4 plus 3, and here 4 plus 1 5 plus 2 7. Sulfur, 1, and here also 1, right? Now we need to balance this. In this case, on the right hand side there are 2 sodium atoms, on the left hand side only 1. So just write 2 here. Let's see, let's just write 2 here and let's see. That means the number of hydrogen, carbon and oxygen atoms also changes. So 2 sodium, hydrogen, 2 plus 2 4, right? 2 here and 2 here. 2 plus 2 4. And carbon, 2. Oxygen, 3 2s are 6 plus 4 10, right? So on the right hand side, the number of sodium atoms balanced, but hydrogen not balanced. So in that case, if I write 2 here, 2 into 2 4. So the number of hydrogen atoms are also balanced, but carbon only 1 on the right hand side but 2 on the left hand side. In that case, if I write 2 here, so 2 carbon atoms, even this is balanced, and balance the number of oxygen atoms now. 4 plus 2 plus 4, right? It is 10. And sulfur, only 1 on the left hand side and 1 on the right hand side, so it is balanced. And this is the balanced chemical equation. Alright, so see how easy it is. Only you need to add 2 here, 2 here and 2 here, so it is very easy. So this is all about balancing of chemical equations. In this video we discussed the definition of a chemical equation, information provided by a chemical equation, limitations of a chemical equation, why should we balance an equation, and balancing of chemical equations. So I hope this video is helpful to you all. I have provided a PDF link in the description box in which I have given few equations to balance. Just balance those equations, and if you have any doubt, post that in the comment section. Thank you so much for watching the video.